Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today we're going to talk about a confidence interval for two means. The addition of bran to the diet has been reported to benefit patients with diverticulosis. That's a big word. Several different bran preparations are available, and the clinician wants to test the efficacy of two of them on patients. By random allocation, the clinician selects two groups of patients aged 40 to 64 with diverticulosis of comparable severity. Sample 1 contains 15 patients who are given treatment A, and sample 2 contains 12 patients who are given treatment B. The transit times of food through the gut are measured by a standard technique with marked pellets, and the results are recorded. So here we have our sample 1 and our sample 2. If you're following along, you'll want to pause the video here and put this data into your calculator. Well, to start out, we're going to construct a 90% confidence interval for the true difference in the mean transit times for food for sample 1 and sample 2. For our conditions here, we're going to say this is a two-sample t-interval for means. It was a random sample of 15 and 12 patients. The 10% condition is met, and here we've checked it for both sample 1 and sample 2. But normality, again, is an issue. We don't know anything about the population measurement here, if the distributions are normal or not, and we have small sample sizes that are not more than 30. To address this, we're going to make a graph of each distribution, so sample 1 and sample 2, a box plot specifically, and we're going to look and say, okay, are there any outliers or is there any major skewness? Since the answer is no, we're able to assume that the populations could be normally distributed. So we would make a statement that said the distribution of the two samples does not show any major skewness or outliers, so a T procedure is appropriate. Once we have finished the conditions, we can then move on to calculations. We have a two-samp t-int option under stat tests, and our input here is going to be data. We have sample 1 in list 1 and sample 2 in list 2. We're putting in our confidence level of 90%, and you'll see this pooled option here. We're always going to select no on this. We're never going to pool. That's for a procedure that we're not doing in this class. After hitting calculate, you can see that we get a interval here of -26 and some change to -4 and some change. And then it lists out a whole bunch of other statistics. I would like to note that the degrees of freedom here is looking a little bit weird. We're used to using whole numbers for degrees of freedom. In the calculator, there is this really big, scary formula that they use to calculate degrees of freedom for this type of test. You don't need to know the formula, but just realize that's why this is a decimal degrees of freedom instead of a whole number degrees of freedom. Our final step is to write out our conclusion, and we can say that we are 90% confident that the true difference in the mean transit times of food for sample 1 and sample 2 is in the interval -26.53 to -4.304. Thank you for joining us. I'll leave you with this quote by Pablo Picasso. Have a great day.